So let's start with our today's session, network automation. So see, we started with those controllers and we were talking about Cisco SDA, software defined access, right? This was software defined access. Now today we'll be working on some of the most complex concepts which are there into this system. So when we were talking about software defined access, this goes like that. When we talk about software defined, that means we are talking about architecture, and when we talk about access, that means we are talking about users. Now on day one we said that the future of network is DNA, right? That's the future of network, digital network architecture. So by the end of today's session we'll know that why is it so, what exactly we really get in DNA. Okay, so coming back to this SDA, software defined access. So this is just a new way. This is a new way to build the campus LANs. Now, as we know that Cisco is never interested that you throw away your current infrastructure. So they gave some say facilities that yes, you can use that. A very quick recap of the last time what we talked about. We talked about controller, which is just a piece of software, and that would be controlling all the devices, right? Our devices. And due to the direction, we called it that this would be southbound interface. True? And then we were having several APIs, and with these APIs our users were connecting and communicating, so either via script or via say a GUI. Okay, and then several companies came up. They said let's make this entire process easy. So Cisco or other vendors, they created those apps, and those apps, they were once again communicating, and over here also we were having either scripts or GUI, and we called this thing as northbound interface. So this was in a nutshell what we talked about. Now let's dive deeper, and what we now see is that when we talk about SBI, when we talk about this SBI, we know that SBI is as such talking about devices, right? Talking about devices, talking about either our current infrastructure, existing infrastructure, or something which we really want to add into our new networks. So whatever the research and whatever the developments which are going on, that is on NBI. So people are making better and better apps, right? All new things, they are coming up over here. New things are coming up over here. But when we talk about SBI, unless and until we don't understand that what SBI is, right, it won't say suffice to understand the whole concept. So over here there are three things. One is overlay, second is underlay, and third is fabric. Now, though it has been mentioned that in CCNA they won't be asking you this thing in too much of depth, but actually, say if we just go by the points that okay, this is the definition of say VxLAN, this is the definition of say ETAP, actually it happens like it happens like you are cramming. So that's why for time being, forgetting about the Cisco exam, we'll be going into the details of it so that the entire concept becomes crystal clear. We actually understand that how in future all the networks will be going. So we'll learn first some concepts. We know that this SDA is nothing but it is a software, right? It is a software, and when it is communicating with other software, so there has to be something to connect them. So there is a mechanism to create, and this is what is called as the VxLAN, right? This is what is called as the VxLAN. This is, we know that what was VLAN, but this VxLAN, yes, this is like similar thing but way beyond say our normal VLAN. We'll see this thing in more detail, or let's first finish this VxLAN only, right? So we see what is VxLAN. Let's start with what we already know. We know about VLAN, and in VLAN we used to say that VLAN 1, VLAN 10, VLAN 20, 30, right? Those VLAN IDs, they were 12 bits. So we know that 2 raised to 12, that means at the most we will be able to reach to 4096, and 0 is not included. So that's why 4095 were the maximum VLANs which we were getting. Okay, 4095 VLANs is what we were getting. In case of VxLAN, this is what is called as the scalability. From 12 bits we have now got 24 bits, and when you have 24 bits, so obviously the number will jump on to 16.7 millions, 2 raised to 24, right? It is 16.7 million. And what is that? It is called as the VNI. The way we were calling over here as VLAN ID, so over here how many VxLANs are possible? 16.7 million. And the way we were calling VLAN ID, so over here we'll be calling VNI. What VNI is, it is very simple. It is just virtual network. It is virtual it is virtual network instance. So it is instance. So that means we can actually create 16.7 million instances. So this is similar to, just for an example, right? We say that this is VNI, let's say 15,000, and there is a router in between, and there is another VNI number, let's say 20,000, and they are communicating. From understanding point of view, this is not very difficult. You can say that, say the way we were talking, that this is VLAN 10 and over here it was VLAN 20. and there was a router in between, and all those things what we were talking about. One question comes that why they have, say, bumped up this whole thing to 24-bit. Why was it really necessary? The reason behind it is that, see, all the businesses and all the networks, they are expanding at a very rapid pace. Actually, if you really see that, let's say if you are a service provider and if you have got, say, 4000 VLANs, to be precise, say 4095 VLANs, and if you are serving just, you are giving them 10 VLANs per customer, so at the most you can serve about 400 customers. Now this is like 400 customers, so it's not a very big thing. But the moment you come up with the concept of VxLAN, so this is good. Now this is where you can serve a huge number, right? So this is definitely a better situation because we have got now 16.7 million. Now in both the cases, the vital thing is that end users go back to let's go back to our understanding of VLAN. In VLAN, this entire game was only at the level of switches. End users, they were completely unaware about that they are belonging to which VLAN. They were completely unaware. This entire process was completely transparent from the user perspective. That is, I am talking about VLAN. But the same thing is even in case of VxLAN. VxLAN is also completely transparent from the user's perspective. They won't be understanding, they won't be even knowing that to which VxLAN are they belonging. Now, if we say this statement, then how was it possible? It was possible because this game was only on the level of switches, correct? That was on the level of switches. So the moment when it is switched to switch communication, so they were coming into the picture of, you were defining that this is VLAN 10, this is VLAN 20 on the ports, on the specific ports. But when it comes to, say, when the user is connected, so well, from this point onwards, the entire VLAN information is stripped off. So user will never be knowing that they belong to okay. Voice is mono, okay. So it is coming via only one channel. Okay. Now is it okay? Okay. Okay, done. All right. Sure. So we were talking about that from switch 1 to switch 2, So when we connect laptops on both the ends, from the perspective of, say, from user, this VLAN is not having any significance from the user's perspective. It is the game of switch. So same thing will be in case of, say, VxLAN. It is the administrator who is handling all these things. And the smart thing is that because of this big number, because of this 16.7 million, you have got so many possibilities. Okay. Now what this VxLAN is, what VxLAN does, it creates virtual networks, right? It creates all those virtual networks, and these virtual networks, they are on existing network. Now when they are occurring on existing network or existing infrastructure, this means at this point of time we are not adding any new devices. Those devices, they are completely compatible with, say, this new DNA, etc. We are working on only those devices which are into our existing network. Now will we be able to create VxLAN on all of them? So for that we have to understand two things. First, what is overlay and what is underlay. So actually you have to think a bit. How is it? Say overlay is where the VxLAN itself would be communicating. I'll just draw a figure also to make this thing more clear. But just remember that overlay is a separate thing, underlay is a separate thing, but they are interconnected. So what exactly underlay is? Underlay is, you can say that your existing infrastructure, right? This is your existing infrastructure, but still more important in this is that only layer 3. So this is your infrastructure, your underlay infrastructure. This is all layer 3. So all layer 3, that means there is no trunking, there is no STP, because see, when there are switches, then and then we have to worry about that. Okay, we have to run STP, we have to run say RSTP, etc. But when we are dealing with, say, underlay, that means whatever we are doing, everything is on layer 3. So then what was overlay, right? What overlay was? It is the overlay where we'll be creating VNI. And in this VNI, so our each VNI, virtual network instance, is, this is now making things interesting. Each VNI is network, okay, and this network is running on underlay, right? It looks very cryptic. Means overlay, underlay. That means in overlay, our whole purpose is to create VxLAN. And when we are creating this VxLAN, right, we are defining it like VNI by giving a specific number. And this VNI is as such a network, and this network would be running on underlay. Right? I just give that there is another name also of this VNI, and that is called as the bridge domain. Right? It is also called as the bridge domain. We'll make this thing still more clear as we proceed. But when we say, now remember, this thing looks bit cryptic, but think about when we were talking about say those, this is VPNs. In VPN we were telling what? We were telling that VPN is carrying our personal data on public networks, right? That is what we were talking, that it is our personal data or the private data that is encapsulated, and then it is traveling across the public network, because internet is public network. And then this is router 1, this is router 2, and then it was reaching to the opposite side safe, right? And then there was confidentiality, integrity, and auditing. All those things were there. So over here also, understand, not exactly like this, but understand on the same roots, right? Same style. This is, there is a network. So obviously when we are talking about overlay, and when there is VxLAN, you are creating VxLAN and you are identifying those VxLAN as VNI, right? And when it is VNI, so then we require what's called as the encapsulation. So it means it is the encapsulation which would be coming into picture. Now over here, the best part is that there would be two encapsulations, UDP and IP. There would be two encapsulations. We'll see in more detail. But same way, when we were talking about VPN, we were encapsulating our entire data, and then we were putting it in on internet, and it was traveling. So same way, it is the overlay where we are creating this VNI network. Now that network would actually be running on underlay, right? But we'll be encapsulating it. So you can say that the function of underlay is transport. The function of underlay would be the transport. And as things will reach to the destination, when it will reach to the destination, they will be decapsulated. They would be decapsulated, because we don't want that user should be in trouble. User should be getting a completely seamless experience. So the encapsulation which is done at the beginning, that should be decapsulated at the end. Now we give some name to these things. Okay. Now as this entire game is occurring at underlay, right? So you can say that it is like two floors. So obviously we call this thing as overlay and this as the underlay. This overlay is telling that okay, this is the entire network, right? This is the entire network, right? Whatever, this is the network. That's how, say, they are all connected, and this is the source and this is the destination, right? Let's connect like this. Okay. What overlay would say was, I want to go from A to B, and that's it. I want to go from A to B. That's what overlay would say. Now how you reach from A to B, underlay, that is your problem. I am not coming into that part. You just reach from A to B, because I have given a parcel to A and it would be collected at B. Getting it? See, you are assigning a work to A, that okay, this is the parcel and deliver it to person who is over here. So that's it. So overlay will be talking in that fashion. Overlay will be telling that okay, say this is VxLAN, say 11111, right? And it should be traveling from point A to point B. It is the trouble of underlay. Underlay would say कि okay, say the best part at this point of time is this. So I'm taking it via that path. Overlay would say, oh, do whatever you want, just it should reach. So it is the underlay which is working on the process of transport, and overlay which is actually handling the whole network. So that's the reason that when we talk about underlay, it has to use, it is not the rule, but ideally it has to use dynamic routing protocols. Right? It has to use dynamic routing protocol. So in case if one of the port is down, or the path changes, cost changes, you know all those things, right? So it will select the best path, so OSPF and EIGRP. But over here actually things which are in use is ISIS, intermediate system to intermediate system. This is the reason that now this sentence would make a sense, that underlay, right, underlay can be changed. Yeah, underlay can be changed without changing overlay. True, right? Because overlay to is just telling that I should be able to reach from A to B, but that's it. Overlay is interested in only one thing, that there should be from A to B, there should be IP connectivity. If you are changing the path, it will say underlay, no problems, do whatever you like, but it should reach. So this is first concept. Now we dive deep, that when we really talk about, say, all these things are happening, so actually what really happens at both these layers? Say VxLAN, you can configure, right? It's like a software thing. So we can say that this is like a spatial interface. This is like a spatial interface, and this interface we call it VTAP, right? There would be few new names. VTAP. What VTAP is? It is virtual tunnel. The moment we'll see the full form, it will make a complete sense. Endpoint. Oh yes. So this is quite sensible thing. Virtual tunnel endpoint. So over here we have got one device over, let's name it as A, this is B, and we are creating a tunnel, right? We are creating a tunnel, and this is a VTAP. So this would be a VTAP, this would be a VTAP. There can be other VTAPs also, but this would say that this virtual tunnel endpoint, what it is doing, it is creating a path, and this path is for whom? This path is for VxLAN only. This path is for only VxLAN, no one else. Only VxLAN would be understanding this VTAP point 1 to point 2. So this would make a complete logic that what will be doing at VTAP? It is nothing but the device which is at A, and over here let's say we have connected this our laptop, and when it reaches to this switch to whom we have said that okay, you are VTAP, so all you will do is you will do encapsulation. What would be encapsulated? The data which is coming from this laptop, from this our innocent user who is not knowing anything about this, that data he'll say कि अच्छा Baba, send it to opposite side, send it to my friend who is over here, right? They both are users. This A would say, this time I'm sending this thing via VxLAN. So when it is sending via VxLAN, it would be encapsulated, like Amazon works user and Amazon is whole and delivery process is underlay. Yeah, true, right? That is very true. A delivery process is underlay, and still say if you say that when the delivery process is handled by some other party, right? That delivery process, when say Amazon is on one end and users are on other end, and the delivery process is actually underlay, and you can say that delivery process, it can be handled by say 5 companies. So users and the Amazon, right, they said that yes, things should reach from say from Amazon warehouse to users, and then the entire delivery, it occurs on the level of those companies. Yeah, good. Okay, so coming back to this, it is this A who tells that yes, over here the encapsulation should be done, because then and then this VxLAN game would start, and this encapsulation is first there would be UDP encapsulation, then once again there would be one more encapsulation, that would be IP encapsulation, and then the things would start traveling. This entire encapsulated package will reach to opposite end, and at the destination it would be decapsulated, right? Okay, so far things are good. Now in case of say VTAP, once again we are writing this is virtual tunnel, their endpoint. Now technically speaking, yes, the way we say that yes, this is one cell phone and this is another cell phone, right, and then they are let's say talking on WhatsApp. So as such, if we draw it like this, it is not in reality like this. There would be so many devices, so many routing devices, they would be in between, but from the user's perspective this entire thing is transparent. Like we talked about that this is Amazon and this is, here we are. So our package, it must be changing so many hands as it is traveling from source to destination, right? So this is like overlay and this is underlay. Right. Now this VxLANs, right? So we are coming back to this concept. VxLAN, now we are making it interesting that this can run on hardware. Yeah, that is good that it can run on hardware. That means it can run on all those newer switches and everything. But let's add something to it. It can run on software also. Now this is again a new twist. It can run on software. Yes, it can run on what's called as the hypervisor. And this hypervisor That means something which is needed, which creates all that virtual environment. Say for example VMware ESX servers, or say in case of Microsoft it is Hyper-V, right? So it can run on these. So what does that mean? That this is a host based method. It's a host based system. It's a host based system. So if you can create this VxLANs even on virtual environment, so that gives so many possibilities. And yeah, just a small clarification that when we talk about hardware, so obviously not all, right? We can't expect that it would be running on those even some old switches, right? Obviously this is a new technology, so it will be running on newer systems. So when we say that, say for example you create a virtual switch, right? You create a virtual switch on a host. So this vSwitch has the capability that you can create VTAP on that. And once you have created a VTAP, that means it will be having capability to encapsulate traffic. Encapsulate traffic. And if it can encapsulate traffic, so that means it can really communicate. So this is how, say, these VxLANs they are working. So when we say that all those physical switches, right, those physical switches, were they working on VxLAN? No, they don't use VxLAN, right? Our existing infrastructure where things are a bit old, so they don't use VxLAN, but that would be used by those newer devices or this hypervisors. So this leads to that only one thing, that overlay is handling those VxLANs and our underlay is handling the transport. Say for example, so when we say that VxLAN, yes, so where we'll run, we can run it on, say, Nexus switch, right? Nexus switch. So when we are running VLANs, right, VxLANs on these Nexus switches, so our VTAPs, one more thing, our VTAPs, they are nothing but VxLAN gateway. Right? Makes sense. Because when this was one VTAP, and then here is another VTAP, and we are concerned with that, yes, that's where my data is going. And then it would be the responsibility of that opposite VTAP to decapsulate it. But yes, my gateway is this. This is where, because from here other networks would be connected. So obviously this would be the gateway, right? That would be the gateway. Someone would say that, Arey, over here to there are so many devices. So he said, yes, well, that is the function of underlay. I am least concerned. I am overlay. I am talking about VxLAN. So that's why this is my next VTAP is my gateway, right? A very conceptual thing, but the moment you visualize it, it becomes much easier, right? Especially when you think from the perspective of, say, like those VPNs. When we learnt VPN, this in-between network was completely transparent. To make this concept still more strong, and plus some of the very important concept of what's called as the jumbo frame. So VxLAN headers, right, over here we talk about VxLAN headers because this makes entire concept so clean. So how these headers they are formed. So first, in order to understand the header, first we have to watch for that how the encapsulation occurs. Though we have already talked about, but still just quickly we watch it. How encapsulation works. So over here, this is our laptop, right? And that's our VTAP. VTAP means this is some new switch, right? Who is understanding the language of this VxLAN. So things would start, and here is our entire network, right? This will obviously be the underlay. This would be the underlay, right? So over here, it is at this junction. Let's say this is A, right? So at this junction, what this would say? A will say that this is my source IP, this is my destination IP, this is my source MAC, and this is my destination MAC. That's it. But it is this VTAP would say no, this is fine, but I need to add something to it. I need to add header, so that I hide your entire data, because this will be displayed only on my last VTAP, and from there it would be delivered to this B, right? It would be the last VTAP, and that's how it would be delivered. So it will say, what will we like to add? Well, we would like to add VNI, virtual network interface. So it's like we have to create a path, right? And we'll be giving some number to that path. So that number, which will be, say, any number from 1 to 16.7 million. So that is virtual network instance. In order to do this thing, first it would say that chalo, this is your frame, right? This is your normal frame. Let me add something to it. And the first thing it would say that let me add a VxLAN. So it would add a VxLAN. Then it would say, as this entire system would be working on UDP, so I need to add a UDP header. And in this UDP header, your source port is random and the destination port is 4789. Then on top of it, it would say, no, this much is also not sufficient, because we are dealing with layer 3. So on top of it, we have to add what's called as the IP header. What would you like to put this in? In this, we would put destination VTAP. And then finally, there is Ethernet, right? Ethernet, in which we add the MAC address. And this whole thing, this entire thing will move to the destination VTAP, going via underlay, right? Going via underlay, and here it would be all headers would be removed and package would be delivered. All headers would be removed. We'll take one example of this. Now this is, as we said, that we just added all those headers just without thinking that, okay, we added this and we added that, right? We added so many things. But actually, it's like that in our car, we said, acha, theek hai, aap bhi baith jao, right? So finally, it is going to overload. So see what happens over here. When we are adding the VxLAN, we are adding the VxLAN, and VxLAN is say 64 bits, right? It is 64 bits. Now in this 64 bit, see the possibility. We said that VxLAN to will be using only 24 bits for VNI. Very true, very true, because it has the first 8 bits, they are reserved, right? Out of 64 bits, first 8 bits are reserved. Then we have got our this favorite VNI, and yes, it is having 24 bits. Then once again there are reserved bits, another 24 bits, they are also reserved, right? So 24, 24, okay. And then there would be 8 more bits, then there would be 8 more bits. This is called as the flag. Now this flag is also very interesting. Flag said that yes, 8 bits, so 1 2 3 4 5 6 7 8. Out of this 8 bits, it is the only bit 3 which is important. Bus, this bit should be 1. If it is 1, so that will say that yes, this is a valid VNI. So what about the rest? Rest are reserved. Rest 7 bits, they are reserved. So this means that this is such a new technology where there is so much of space for all those improvements. Means you can you think of a function, and when you think of a function, you feel like, yes, I want to add something to this VxLAN. Yes, you have got so much of space. You have got 8 bits over here. You have got full 24 bits over here. You have got 7 bits over here as a flag, right? So you want to add some security feature to it. So yes, you have got so much of space. You have got so much to play with. So this is the reason that whenever the new technologies they come, they keep all these reserved bits for the future expansion and for the future, say, features when as and when they come. But then there is something which results because of this. See what happens. We just kept on adding this feature and that feature, and then we added those reserve bits, and then we added that UDP encapsulation, IP encapsulation, and again we are not talked about whether it is IPv4 or V6, and then the Ethernet. Let's do that, and then we realize that what we have really done, right? So result of all this, we said everyone ke theek hai, you also sit in my car, you also sit in my car, and then see what happens to our car. We start with VxLAN. In VxLAN 64 bits, so we write over here in bytes, so it will become easier. 8 bytes. UDP, we said yes, add the UDP also, so that is another 8 bytes. Then we said that there would be IP header, so if it is IPv4, so then it is 20 bytes. When it is IPv6, so it would be 40 bytes. And on top of it, we said that there would be Ethernet encapsulation, right? Ethernet encapsulation. So that Ethernet encapsulation itself is another 18 bytes. The only good thing is that because of all these things, we don't need FCS. Frame check sequence is not needed, so those 4 bytes would be decreased. But in any case, if we make a total 8 plus 8, 16, 16 and 20, this is 36, 36, and this is 18. And the plus 36 and 14, this 4 minus, so that comes to 50. And when it will be IPv6, so another 20, so it is 50 to 70 bytes. 50 to 70 bytes. This is huge, right? This is huge. 50 to 70 bytes of header. Now, when you do this, this would exceed the limit of a normal Ethernet frame. And when it happens, right, immediately it will lead to what's called as the fragmentation. So solution, that because it is exceeding the normal frame, and yes, it is bound to go for fragmentation, and when there is fragmentation, this means it is extra work, and when it is extra work, so that would decrease performance, right? It would decrease performance. So there has to be some solution. Well, solution is there. Solution is that you have to enable what's called as the jumbo frame. Simply, passengers have increased, so now they are not car ki savari, right? We have to deploy a truck, and then everyone will go in a single round. So that's the concept of jumbo frame. Okay. To add something to this, say you must have heard at so many places about Lisp, right? Lisp, Lisp. Lisp is list processing, right? It is what is called as the list processing. We'll be discussing as we'll proceed that Lisp is used at so many places, but because it is important topic, so that's why I'm just taking it beforehand so that there is no confusion as we use this word repeatedly at so many places. So Lisp is list processing. Now when you'll read from the book, you'll find that some topics we are taking some topics before, but we are following this concept that whatever the term which we use, if we have discussed it beforehand, so then our understanding improves. Because after telling that, okay, this is a Lisp, a map Lisp server, this is what it will be doing, this, that, everything, and then after certain stage we'll say that what is Lisp. So that is like an injustice. And in fact, this is so interesting. Right? So this is list processing. Now you'll be utterly surprised that this technology, it came in 1959, right? And it was John McCarthy. He made this concept. Now at that point, it was not made for something what we are using today. Yes, this is true what I said, what you heard, that Lisp is used even today. The basic function of any of the Lisp is for manipulation, right? For manipulation of data strings. When we know that in data there are several strings, right? There are several pieces of information. Lisp is that where it can really handle these things superbly. And this is one of the very old technology, the oldest technology which is still used. In fact, I should add the word still widely used. It is not so that it is just used for small things. And the best part is that it is used for AI, artificial intelligence. Yes, this is something which is used for artificial intelligence. Lisp, it is used even in the SolidWorks. It is also used in, say, AutoCAD. So when we really want to, say, process some very complex meshworks, it's because Lisp provides, no doubt we are going beyond and we are deviating slightly from our main topic, but doesn't matter. We'll come back to our main topic. But what Lisp provides, this provides very high level of debugging. Right? It provides very high level of debugging. Now you know that debugging is something which is very good for diagnosis, right? Troubleshooting. It also supports it is object oriented programming. It is for object oriented programming. Say in very simple words, if I say that when we talk about say Microsoft Server, right? Let's take that simple example, Microsoft Server. So in Microsoft Server, this is just to explain that what exactly is object. Everyone is object. User is an object, printer is an object, file is an object, everything is object, everyone is object. And then the game starts that what right this object would be having on second object. So this is object 1 and this is object 2. So what right this particular object will be having on this second object. So over here even time will be an object. So again there would be a third object coming into picture. Then it is like if your printer is having so many functionalities, so then they are called as the properties. So you can go to the granular level that every object would be having their individual property. So what I mean to say if this is a user object, so if he is a user object, so then this user object will be having a property, let's say phone number, right? A phone number. So let me write, let's say his one of the property, he will be having name, right? So let's say this is user object 1. So he has got property of name, location, right? And the phone number. I'll write it as cell number, right? His cell number. And this is our object 2. And this object 2 can have name. Yes, printer can have name. Printer can have location. Yes, this printer is located on 3rd floor and this particular office. But can it have a cell number? No, it cannot have a cell number. So then what other property? It can have a property like to print. And to print in, say, this is a very high sophisticated printer, so it can print in color. But no, for everything we don't want to print in color. So it says that yes, I can print in black and white and I can print in color. So these are my 2 properties. You can go to that granular level that this particular user cannot print a color copy after, say, 1800 hours. That is after evening 6 p.m. he cannot print a color copy, but well, he can print this black and white. This is what is called as the object oriented system. So Lisp is something which is very good in handling this object oriented programming, right? One more thing which it is very good, the thing what is called as the very fine macro systems. Very fine macro system. Now I give you one more example of that, what exactly it really means. Say what you are watching right now, right? Or what YouTube, say how the YouTube live is working. YouTube tells that, well, if you just want to put the webcam and just want to speak, so then you don't have to worry about. You just use your normal laptop and things will be fine. But if you really want to show some pictures, you want to show someone that you are drawing something and then it is getting displayed, so then you have to use something what is called as the encoder. When you are using this encoder, everything is connected to this and then it is streaming, going to YouTube servers, and via multicasting it is distributed to everyone. So this is the encoder. Now encoder has got so many features, so many switches, so many settings. Now what it happens is like that if I say that as you are watching this and I just want to remove, right? See, we are, you are watching the logo over there, right? There is a logo over there. And we really want to remove this logo. Now, in order to remove this logo, I am telling that what exactly is the procedure. It is like in OBS, which is my encoder, right? There are various scenes, and in that there is one scene which is training. In this training there are several sources. So there are sources like where my Wacom is connected, where my this digital, say my display is connected, and then there is something which is creating the frame, right? And then there is those images which are linked. So I have to actually go into that source, I have to go to that image, I have to remove it from this source, and that's how it would be displayed. Now if I start doing this procedure, right, so it would take some time. Now see, when I'm using macro, what happens? Within, say, split second, this entire thing can be removed, right? So I am just doing it. See what happens as I press a button and boom, gone. If I want to add it, and I'm doing, I'll tell you how I am doing it. And when I press this, and it is back, right? How I did that? There is a system what's called as the Elgato, right? This is what is called as the Elgato. In Elgato, this is a macro based system. You can define several macros. So it's not so that I say when we'll be discussing, let's say when we'll be discussing some high end on, say, practicals. So just by, because of this Elgato, where it can carry thousands of macros. The only thing is you should know that how are you defining it. But this is a system by which you can define all these macros. This is the importance of Lisp, right? So where you can define all sorts of macros, and then you are using those macros for your specific purpose. Okay, one more thing, that that Lisp, it can handle so many different types of database. It can handle very wide variety of data types, right? So that's how this Lisp comes into picture. Now where will we use Lisp into, say, our discussion? Say we talked about VTAPs, we talked about those let's say headers, encapsulations, right? So in this case, let's draw a figure, and that would make the concept crystal clear. Let's say this is our switch 3 and this is our switch 4. Now there is something what is called as the EID, end point identifier, endpoint identifier. So this endpoint identifier, is just doing one thing, that let's say this is our network which is connected to 10.130/24, and similarly we have got, say, 10.1.4 4.0/24. So we have got two EIDs, endpoint identifiers. That means they are the networks which are connected to our switch. And the actual, it is now called as the R lock. What R lock is? Say 172.16.3.3. This is the IP address, because all this thing is layer 3. Nothing is in layer 2. Everything is layer 3. So that's why even these switches, they are like layer 3 switches. And similarly over here, the routing locator for this switch, let's make it say 172.16.4.4, right? Just for the ease of understanding. So this is switch 4 to 4.4, that is 3 to 3.3. R lock is routing locator, right? Routing locator, as we shall be crossing networks. So that's why routing is necessary. The main over here is our Lisp map server. Now, as we said, that Lisp has got tremendous capability to handle all sorts of devices, right? So when it is handling all different devices, what it will do, it will say that let me make a list. So all of you come here and just let me know your situation. So everyone would come up and will say that let's create the table, right? And it would say this is EID and this is R lock. The switch 3 would say that I know where 10.1.3.0 network is there. So then Lisp would say, okay, that's okay. So then how should I be able to reach to you? He said, okay, come at 172.16.3.3. We'll say okay. Same way for this, it will say this is I'm handling 10.140/24 and my R lock is 172.16.4.4. This thing is prepared. Now starts the real fun. Someone comes, right? Some switch 1, it comes. It tells I want to go to, I have got a user, and this user wants to go to say 10.1.3.0. I want some information. So this switch is not knowing anything about that who is say 172.16.3.3, who is switch 3, who is switch 4, nothing, no idea. It would simply come to Lisp server. Okay, yes, I want to go over there, right? So if I take it like, just to make this thing easier, so if we make it like this was step 1, right? Let's say this is step 2, and say this is formation of our this map is number 3rd step, and this demand is 4th step, and then this switch 1 approaches our Lisp server, that is a 5th step. So then Lisp would watch its map. It would say that yes, there is presence of 172.16.3.3 because he is handling 10.1.3.0. So this is the entry of choice, and that becomes step 6, and then it would approach switch 3. So this is step 7, and then switch 3 would say, okay, you don't worry. Switch 1 wants that information. I am sending, and it would be sent, and this is step 8. So that's how this entire game works, right? Now let's see how we add this thing into header, so it will make things still more clear. Just remember those IP addresses, right? Okay, so let's say this is our original data, right? And what it is telling that I want to go to 10131. This is what our laptop is crying about. I want to go to 10131, right? 10131. That switch 1 will say I don't know anything about 10131. तो के कुछ नहीं, के go and talk to Lisp. So then it is the Lisp which comes into picture. And now the header is getting prepared. So it will add VxLAN, it will add UDP, and in UDP we talked about that it is the 4789 port, because this would say that yes, now VxLAN action is coming into picture. So this IP address, as you must have guessed, yes, it would be RLOC. It would be 172.16.3.3, right? So now the whole battalion will start moving towards 172.16.3.3, and once it will reach over there, this entire portion would be removed, and then it would say yes, 10131, yes, carry on, and it will go, right? So this is how the VxLANs, they actually work with their entire system. And in this case, say our switch 1, there is a special name given to this. This switch 1, it is just कहने को ही switch. Otherwise, say it is ITR. What ITR is? It is ingress tunnel router. Fine. So now the most difficult portion was this only. From this point onwards, things are very, very simple. Very, very simple. It is, in fact, so much of, with this understanding, say this rest of the discussion would be damn easy. So we talked about SDA overlay. This is SDA underlay. What SDA underlay? It is just connecting all those nodes which are into SDA environment, right? So its function is the transport of VxLANs. But now you have got two options. You will say that there are two options. The option 1 will say that we'll keep on using those old devices because we can't throw them. So try to add some new configuration if it is possible. So this is option 1. Second option, that let's go for new devices, everything new, but can't throw away old devices, so we'll keep that also. So the idea is that all these old devices, right, they are just helping. We are just doing it in such a way so that all those endpoints migration is possible to new SDA. So our old devices, that is our current infrastructure, is now understanding that what exactly is VTAP with the help of that new configuration. So we are teaching them some new languages. We are teaching them some new tricks, that this is how now you will be communicating. Because those new devices means they are already understanding this entire thing. It is coming pre-built. So then there is nothing to worry about. But it is this old device to whom we have to teach new tricks. Now there are some issues, right? This is something important. So issues in adding, we just can't add things as such. Say we are adding SDA, software defined access, to our existing network, right? It is easy to write it down, okay, just add, but then you can't teach all those new tricks to these old equipments. Now when we are trying to do this thing first, and this is the vital thing, in case if we harm to existing networks or the existing devices, if something goes wrong, and then in case if it is a production network, right, if it is your production network, so then yes, it is your production network, so then don't use the newer technology like say DNA center, because DNA center is for management, to configure underlay, to configure underlay, right? We are dealing with underlay. Say if it is your vital production network and then you try to manage it by say data center, and if something goes wrong, so then this production network or say high security networks, or when any of the military operations they are in progress, so then you don't play, no such games. Now you decided that yes, it is time and we really want to upgrade it and we want to make changes in it. So then before you proceed that chalo DNA center installed and then let's take over this entire existing network, watch for this thing what is called as the SDA compatibility. Otherwise it's like you are shouting and that device is not understanding. There is no point. That device is not understanding your language at all, right? So this SDA compatibility list is very important. So it should be like that yes, your existing devices, right? We know that these existing devices, they are old, but at least they should be able to understand this new language. And that is where you'll go to Cisco site and you'll go for this SDA compatibility list, and your device should be present into that. If not, right, if not, so then they are too old. They are too old to learn new tricks. So then you have to say bye bye to them, right, if you really want to go for this newer structures. So this is SDA compatibility list, and this is at say cisco.com/go/SDA, right? So here it will be showing you list of supported hardware, whether they will be really compatible or not. Yes, one more thing, say it will also show you list of supported roles, right? List of supported roles. Now what are these roles? The role is that hardware is one thing, but what it can do or what it will do. say first thing, that one of the role could be say fabric. Whenever we say fabric, so then you understand that we are talking about network. So it is fabric edge node, right? Edge node. So this edge node is what? It would be behaving like very similar to a traditional switch. It would be behaving like a traditional switch. So this traditional switch is doing what? It connects to endpoint devices, right? It is connecting, or it connects to endpoint devices. Endpoint devices. So if you say that yes, this switch is compatible, so then is it compatible for fabric edge node also? So that is also mentioned at cisco.com/go/SDA. Then there is another role, second role, that is what is called as the fabric border node. Border. So this is what? This is that switch which is outside SDA's control. This is a switch which normally you connect to your WAN router or something which you connect to your data center, right? So this is something which is outside the SDA's control. So that switch is called as the fabric border node. So in case if it is not supporting edge, so it will go there, it can go there. And this third thing is, this is what is called as the fabric control node. Technically speaking, this is the vital. This is that special function switch, right? This is that special function switch which would be handling, or which would be taking care of the control plane function for underlay, right? This will take care for say control plane function of underlay. So this is good, but when we see this thing, that who can really take care of this switch will obviously be someone who will be having say better CPU and memory, because this controlling is something which always requires high CPU and high memory. And this is where the Lisp will come into picture, because this entire handling is by Lisp. So this processor should be Lisp compatible. So this is the reason why we talked about Lisp very in advance, that the whole function of Lisp is to handle these structures in a very efficient way. So when we talk about the fresh SDA design, right, something which we say that let's start a fresh design, so this is where we need and we use SDA compatible hardware. True. SDA compatible hardware. So just for the comparison, that the fundamental difference at this case point, right, the fundamental difference between our traditional network and our SDA network, it is, say over here we were dealing with L2, L3, correct? We were having issues of spanning tree protocol, then we were doing rapid spanning tree protocol, then for the redundancy we were using HSRP, right? This was for redundancy, or collectively it was called as the FHRP, first hop routing protocol, redundancy protocol. Over here, the first and most important thing is that all switches, they are like L3, and the protocol which we'll be using is ISIS, a very powerful protocol, but this is very light, runs very fast. So this is the routing protocol, and because everything is L3, so there is no question of STP or RSTP, nothing like that. This thing we talked about, that your SDA edge, right, SDA edge, that VTAP, that VTAP would be your default gateway. Good. And obviously when everything is layer 3, so we don't require FHRP. If one path is not there, then ISIS will figure out another path and will go via that route. So this is like a basic difference between both of them. Now what Cisco is telling that you go for DNA, digital network architecture. It is the DNS center. They say that this is the future, right? You can go to cisco.com/go/DNA center for more details. But in nutshell, it has got two roles, just two roles. The first role, and in fact this is more important obviously, where it would be acting as a controller in network. It would be acting as a controller, right? Using SDA, software defined access, where you'll be defining those, say, controllers, and you'll be working on it. And second is network management platform. Network management, right? This is management platform. Obviously, this management, it would be for traditional network, where they cannot do any other function. So it is like DNA would say, if not more, so at least I should be able to, say, manage it for traditional networks. So this Cisco DNS center, this Cisco DNS center, right? It is a software. It is a software application. And this software application, it is pre-installed on Cisco device. Let's say a Cisco server. So it is pre-installed on Cisco device, Cisco DNS Center appliance. So this way, so it goes now something like this. This is like a DNS center, and then it is handling all those devices, right? It is handling all those devices. And these devices, if they are an old device, so then they will be handled by, say, Telnet or SSH, or SNMP. Right? So this is for old device. And all for those new devices, so it will say that I have got some new things for you, like say netconf or restconf, and right from the beginning we are telling about that this is SPI. Good. And regarding others, so users, whether they are connecting via and handling via scripts or GUI, so they are getting connected and can create some apps, whether it is by say Cisco or it is by some other third party. That's okay, whosoever creates those apps, right, they will be also communicating. In both these cases, it is the REST API which will be operational, right? So over here also you will be having say GUI, or it can be a script based thing, so where things are getting communicated via API. Okay, now as we are talking about say Cisco DNA so much, so there has to be something so good about it that it is a candidate for all those future networks, right? So some main features of Cisco DNA. Now before telling about this feature, let's go back to our ACL, access control list. We used to make those access control lists. So let's say we prepared one ACL with 1, 2, 3 statements. Then some new requirement came up. We added 3 more statements. So 4, 5, 6. Then something again a new came up. And this list started growing. Now at one point of time, the trouble is you can't remove this. This list can't be removed, because you really have to understand that what was the purpose of these first 1, 2, 3. Now it was prepared way back, so you have to really go back and you have to figure out that what exactly was the purpose of this particular list. Second, even if you find that yes, everything is useful, so then the trouble is length. As the length, you know that all these ACLs, they execute from top to bottom till the match is made. So this makes entire process slow. And as the list is growing, so it will also be a hindrance for the troubleshooting. These are some very practical points and very practical troubles when the list grows. And as this list has been deployed on so many devices, so you have to actually understand the whole concept, that how to go for troubleshooting. Now this is a pain. This is really a pain. Solution: DNS Center, they said that see, we give you a solution of what is called as the scalable groups. Now this concept of scalable group is not very new. It is there. Now it's like, say a new employee comes, right? Someone enters into the company. Now you create his username, and let's say he would be working in a technical department. So do you really feel that for this particular username, right, let's say there are 25 folders where the technical team would be storing their data, and then we had to create email of this person, and we have to assign him rights to, there are 5 printers, and we have to assign rights to all these 5 printers so that he can print. and then we have to create so many even other requirements for this particular user. Is it so that we have to do all these things? No, not at all. It is like there is already a tech group, right? A tech group is there. Tech group has been given all these rights. So all you need to do is you just make him a member of this tech group, and boom, done. This is where you have given all the, you have defined all the policies over here, that well, on printer 5 you cannot print after say 6 o'clock in the evening. On printer 1 you can print as much as you can, and after say 6 o'clock you will be using this particular internet, and if you are downloading, so then you have to use this internet too. All those rules, all the policies, that is what is utilized for the management. But so in CC, this Cisco DNA, it is the same policy. It is the same thing what you can do. You can actually create groups, and then you make all those devices member of those groups, and those devices, they would be behaving as per the policy which has been given. POLICY policy. Huh. So as per the policy which has been assigned to these groups, these policies, they would automatically flow to these devices, and those devices would be working in that fashion. Now currently there is what is called as the Cisco Prime infrastructure. This is something which is available even right now. This Cisco Prime infrastructure, it is a traditional network management. It is a traditional network management product. So obviously this would be, when it is handling traditional network, so it must be having so many good features. Well, so many, and some of the features, they are like actually very good. Say one is that there is just single GUI, right? This is a single GUI which is for everything, for all IP functions, all features, right? For IP functions. Then we have got say discovery, inventory, and on top of it say the topology map, creation of those topology map. So it means the number of devices which are there, and they would be found by itself, and then the topology map is created. This thing is effective for the entire enterprise, for entire enterprise. So means there is no separate product for say LAN, there is no separate product for WAN, and there is no separate product for your data center. Now everything can be handled just by this one product. Second, say it uses the methods and protocols. If you see, it is using all those standard things. It uses say SNMP, right? It uses SSH, it can use Telnet, it can use CDP, it uses LLCP, right? So you see that it is handling wide variety of protocols. Then this is like life cycle. This is what is called as the life cycle management. So in life cycle management, say this is first day when you install a product, right? You install some device. Then on second day, let's say you have configured this device, and on some 10th day, 12th day, let's say you are monitoring that device, and then you are going for optimization after watching it, that how it performed for say last 10-12 days. So that is what is called as the life cycle management. Every device can be handled in this way. And then this is something which is very good, application visibility. application visibility. So let's take the example of QoS. Now QoS, you know that it was so complex, right? But it simplifies this entire system, as you are doing it with the form of GUI, and you are watching this entire process. And then there is, say, converged, wired and wireless network. So from the same platform, you are handling both of them. Now these are the things which were already present into this DNA prime infrastructure, right? But DNS center, when we say that it is a future, so it has to be, there has to be some unique feature, right? Something which should be so appealing that yes, we should be tempted to go for, say, DNA center, and they are. The first is, this is what is called as the easy QoS. That's like an app, so it makes things much easier. Second thing, this is encrypted. Now till this point we were talking about encryption of our data. Here it tells that for the security purpose, even our traffic should be encrypted, our management traffic. So encrypted management traffic. And again, you can even do the analysis of it. This word, it is called as the comprehensive. It is called as the comprehensive view of the health of your devices. And they gave the name 360-degree views. 360-degree view. It means you can watch your device whether it is working effectively or not. Now this fourth point is so good. So that's why just before explaining this fourth point, let's say when we are talking about management of the network, you know, there is one thing which we say, that as soon as you install the device, you take its baseline configuration. Well, I'll explain you something like this, that here is A, here is B, and you are into the laboratory and you are checking hemoglobin. This A's hemoglobin is, say, 13, and the hemoglobin of B is 11.5. Now you will say that yes, this is healthy, this is good, and this 11.5 is low. But man, just before 2 weeks, if someone would say, or if you see the reports, that before 2 weeks hemoglobin of A was 15 and hemoglobin of B was 11. So this means what? This means that this B is doing good, and in fact for A so there is some problem. This is because we were knowing things, that is, we were knowing about the past reports. Now in traditional network, unless and until you have taken all these things into consideration well in advance, so then you know. Otherwise, when suddenly you see that a CPU of this particular machine is soaring at, say, 80%, 90%, so there is some trouble. Actually not, right? Unless and until we really see its past performance, that how was it behaving? Was this device meant for this particular thing? So here, this is something which Cisco has really taken care of, and it is called as the network, right? A very fancy name, huh? Network time travel. Network time travel. You can go back in time and you can see past performance. you can see past performance of that device. So by comparing that, you can really know that whether the trouble is really there or not, right? So this is very interesting. One more interesting thing, it's called as the path trace. In path trace, it you can actually see the actual path it's taking as it was traveling from A to B. You can see the actual path, and this path is not seen just as such. You can even see map of the path, right? You can see map of the path, and this final thing is so good. You can watch even all the ACLs which are coming into path. You can watch all the ACLs, and then on top of it you can even watch that whether this ACL was permitting something or this ACL was denying something. Everyone whosoever is in path, that can be seen, right? So that's the reason that they say that future is this DNA, because one, that it would decrease the cost, second, that it would decrease the risk, because the traffic is now completely encrypted, even the management traffic, and that would lead to better security, right? And as you are taking care of the entire health, so the speed of deployment would be much faster. So faster deployment, and then at your service there are some simplified applications, and these simplified applications is what is giving you the ease of mind, right? So all these things, they are like for the betterment of the network. So this was one of the marathon topic of say network automation. Tomorrow we'll be talking about all those ensemble, puppet, then we'll talk more about those REST APIs, right? So thank you so much, and we meet tomorrow. Thank you.